Alrighty, let's see what we got here. At the middle of the night, sum of distances, medium. You're given a zero-index integer array nums. There exists an array of length nums.length where array I is the sum of absolute value of I minus j over all j such that nums at j equals nums at I and j doesn't equal I. If there's no such j, set array I to be 0. What? Array I is the sum of absolute value of I over j. I don't know what this means. So 1, it's the sum of the distances that have an equivalent value in it, I think. So 1, like this value of 1 is the same as these values, and then you're supposed to take the sum of the distances from this one to the other ones and replace the current index with it. Okay, so this is like 2 plus 3 is 5. 3 has no other values in the array that matches it, so it's just 0. This one has this one, so it's 2 distance, and plus this is 1 distance away, so it's 3. And then this one has 1 and 3, so it's 4. And then 2 doesn't have anything, so it's 0. Okay, this is pretty straightforward, I think, in terms of understanding it. This feels like some sort of hash. So I just need to worry about how to calculate the ones here. So if I have the numbers array that is 1, 3, 1, 1, 2, and then the positions for the 1 itself is 0, 0, 2, 3. So how would I translate this into something that is like 5, 3, 4? Almost think of it. Almost have it. So 2 minus 0, 3 minus 0, 3 minus 2, 0 minus 2, 3 minus 2, 3 minus 0. Very fast way of doing that. Very fast way of doing that. I think. Interesting. So I think maybe if I did some sort of prefix sum on this array, would that work? Like a prefix and a suffix sum. So for instance, if this was 1, 2, 3, it'd be 2 minus 1 plus 3 minus 1. And then it'd be 2 minus 1 and 3 minus 2. And then the last one would be 3 minus 1, 3 minus 2. If I did some sort of, like for a particular, let's say I had some values here. Let's say it's like 1, 3, 5, x, or let's say k, 10, 11, 13. So k is going to subtract everything that is before it within the order. So it's like k minus 1, k minus 1, k minus 3, k minus 5. Those are the distance for k to 1, 3, 5. And then the other ones would be 10 minus k, 11 minus k, 13 minus k. And so I could group, if I take the sum of these 1, 3, 5, that's the total things that k would subtract by. So it'd be 3k minus the sum of 1, 3, 5, which is 9, plus, and then it would be these things, 10, 11, 13, which adds up to 34 minus 3k, where the number of k, this coefficient 3 is basically denoting that there's 3 things here, and this coefficient 3 is denoting that there's 3 things here, and I can just take the summation. I can do like a simple prefix sum here and a suffix sum here. I think that might work. I think that might be the fastest. I mean, it seems like it'd be O of 1 time complexity to do that. Obviously, it would be O of n time complexity to get the prefix and suffix arrays. Okay. And then for each value in the numbers array, I need to take the position of it. Do I want to do this with a default dictionary, or I think I want to do, yeah, this is default dictionary. The values are from 0 to 10 to the 9th. So let's go ahead and say answer 0. Let's say positions is the default dictionary of lists, and this is the key of it is the value in nums, and the value at that key is going to be the list of positions with value. For every value in nums, no, I needed the index. Huh? N is the length of nums. For every k index in range n, say value is equals to nums at k. Position of this value appends this position array of this value appends this position. Yep. And just to verify, let's go and print. So this should be 1 is at 0, 2, 3, 3 is at 1, 2 is at 4. Yep, yep, yep. Okay. Okay. And then I'm just going to go ahead and do for every value. So I'm going to go ahead and create prefix and suffix sum arrays. Prefix arrays are basically something like this. Just doing a simple example array is equal to, let's say 3, 1, 4, 1, 5, 9, right? The prefix array would be the sum of values starting at the start up to that index. So maybe something like 3, 3 plus 1 is 4, 4 plus 4 is 8, 8 plus 1 is 9, 9 plus 4 is 14, 14 plus 9 is 23. So sometimes you want to add a 0 at the start to make it a little easier with the indexing. And then suffix arrays basically summing up to that array from the back. So the last thing is 9. 9 plus 5 is 14. 14 plus 1 is 15. 15 plus 4 is 19. 19 plus 1 is 20, 20 plus 1 is 23. Obviously the sum of the values in the array is like the last entry or the first entry in the prefix and suffix. And it's just going to be quicker to use the prefix and suffix to calculate the sum of the things I want to subtract or get subtracted by. So this is going to be, I guess I want a prefix default dictionary and a suffix default dictionary. Prefix dictionary is equal to default dictionary of list. And here the key is equal to the value, and the value is equal to the prefix array of that value. And I'll have a suffix dictionary. Key is the value is the suffix array of that value. Let's go ahead and do for every value in my position array, which is basically every unique value in the nums array. If the length is 1, which means it only occurs once, like 3 and 2 in the nums array here, I can safely ignore it. If length of position of value equals 1, then continue. Otherwise, I need to iterate over the list. Okay, so let's say current is equal to position of value. I wonder if I should start with 0. I wonder if I should start with 0. I think I probably should be. Prefix dictionary for this value, I guess should probably append 0. And then for every p in the position array for this value, then prefix dictionary for this value appends the last thing, prefix dictionary for this value at the last, plus p. Something like that. I wonder if I should just use a variable rather than use a prefix dictionary value at -1. Probably the same. Okay, and then I guess the suffix dictionary for this value should append the total, which is going to be the prefix dictionary for this value. It's going to be the last thing, right? So 23 is this total sum here. That's the first thing I want in the suffix array. Prefix dictionary for this value at -1. And then for every p in position value, subtract. Suffix dictionary for this value appends suffix dictionary for this value, the last value, minus p. Okay, let's go ahead and just check that this is right. Print prefix dictionary and print the suffix dictionary. That what expected? Yeah, 0, 0, 2, 5. Yeah, that's right. And then 5, 5, 3, 0. That seems right. So if this was 0, 2, 3, then the prefix dictionary is going to be 0, and then 0 plus 0, 0 plus 2, 2 plus 3, and then it should be, well, it should be 3, 5, and then 5, 5, something like that. 5, 5, 3, 0. Yeah, okay, that's right. It should end with 0. Okay, I think that's fine. I think that's fine. And then, and now to create my answer array, I want to say. How to do this. So from the original, say this is the position at some value, right? This is position array at some positional. These are the position of some particular value. I think I want to convert this to the actual things I put in the answer. If that makes sense. If that makes sense. And then what? And then I use a deck maybe. Double-ended queue so I can pop the left side of the queue each time I encounter the value. Guess maybe. Okay. Create a double-ended queue of calculations for the answer array. Let's go ahead and deck this. This is going to be default array of decks. Is that it? Default array of decks. Default dictionary decks of double-ended queues. And I do that. Default dictionary of double-ended queues, Python. I think that's the syntax. Yeah, okay. So I need to go through every position again. So for every value in position, if the length of the position of this value equals 1, then skip it. Otherwise, it's going to go through the current list of positions and calculate. So for every position in the position value, I guess I should probably just use current, huh? Wonder why I created this current if I didn't actually, guess I didn't really need it. Okay. If I just call it, yep. And then I need to do the subtraction correctly. I guess I probably need to know the number of positions here to do it quickly. I need to know the number and the index that I'm currently at. Okay, so let's say pnum is going to be the length of position at this value. And then for every index k in range pnum, let's say the actual position of this value is position of this value at k. And then, so k is like 0, I'm dealing with the first position. So I need to I would need to do the calculation here. The calculation is equal to, it's something like prefix dictionary of this value at this index, maybe at k. I think it's something like at k. So it should be this calculation right here. The number of things that this is after. The number of things that this is after. So if k is 0, this is after 0, k is 1, is after 1. So it should be, I'm going to say k times p, k times p minus, yeah, k times p minus prefix dictionary value at k, at value at k, and then the complement of that would be, this needs to be subtracted. So it should be something like minus pnum minus k, pnum minus k times p. So this is not quite right, I think it's going to be off by 1. So if k value, k index is 0, 1, 2, 3, 4, 5, 6. So pnum would be 7. So I think it's pnum minus 1 minus k. And then there should be something like suffix dictionary at this value, either k or k plus 1. K or k plus 1. So k is 0, 1, 0, 1, 0, 1, 2. I think it's k plus 1. Suffix dictionary at value at k plus 1 is my guess, although I'll just check to see if it's correct. And I think that calculation is fine. And then I would say that the dec of this value, is it append? I think it's append the calculation. I think that's right. And then there's going to be an answer array. and then it's going to be like for every value in nums, if the position of this value, length of that is 0, length of that is 1, then there's just once of these, so answer append 0. Otherwise, it needs to use the deck. So answer appends deck of this value at 0, and then pop left side. Deck of this value, like pop left. Is that how you do it? I think it's all lowercase, but it could be lowercase, uppercase. Yeah, it's all lowercase. And I think that might be it. Ooh, kind of ominous. Alright, alright. There was a much faster way of doing this. Okay, let's think about this. I mean, it's not terrible, but that worked. Obviously, it didn't work very fast compared to others. I mean, Is there just a way to calculate this on the fly without having to worry about things this algebraically? Probably. Let's think about this. 135. How to translate the positions of a value to the distances that might be involved. Translate them. Did I picture this? There's positions. There's positions. There's some number of positions. And then if I add one more position, plus 3k minus 3k. Guess I could factor that out. The k is just going to be how far away it is from the center almost. The multiplier of k. If it's exactly at the center, then if k is multiplied by 0, that's really not much. I mean, I could just use, okay, maybe suffix array was not necessary, since I can just take the total minus the prefix array at the point to get the suffix array. Okay. Yeah, it's been a while. It has been a while since I've done this stuff. But yeah, this is unnecessary, I want to say. I mean, it's probably not going to make that much of a difference though. So it's going to be the total. So for every value and position, okay, let's say the total is going to be equal to position of this value minus 1, the last entry. And then this is just going to be maybe total minus this becomes total minus this thing, kind of. Or total minus this thing where this is k plus 1. It's total minus prefix dictionary of value at k plus 1. I think that's correct. Shucks. Is that not correct? Is it just at k? I'd be very surprised. No, it's just wrong. Okay. Total. Oh my god, I'm doing the wrong thing for total. What an idiot. This is prefix dictionary of this value. The last thing in the prefix dictionary should be the total. And yeah, this should be, I'm pretty sure this should be k plus 1. Okay. Alright, so I took out the suffix array. I mean, that was a sizable improvement. 201, 177. It's 10% or so. Okay. Can I calculate this more on the fly? Can I calculate this more on the fly? Like on the first pass? Do I even need to create a suffix and prefix array? Or do I even need to create the prefix array? Can I calculate this thing strictly on the first pass? I want to say yes, right? Yeah, I feel like yeah, okay. No more prefix array. So I think here I can just say total is equal to the sum of all the position stuff. So sum of the position of this value. And then I think I can just create this thing right here in this pass. So it's going to be for k, do I need to know the pnum? Yeah, pnum is the length of position of this value. For k in range pnum, I'm just copying really this code here. P equals position of this value at k. And the calculation, I guess, okay, calculation is equal to k times p minus think I need to actually know some current value here. I think I need to actually have, eventually I should have current plus equals P. And so this should be something like current it should be K times P minus current, and then plus total minus the P value minus current minus P num minus 1 minus K times P. So it'd be, or times P, so should be able to factor the P. Oh well. It should be P num minus 1 minus K times P, something like that. And then at this point I've gotten rid of this actually. So say deck is equal to default dictionary of the WQ. Okay. And I do need to append to the deck here. Deck dot value. Deck at value appends what the calculation. And then just this same code. Alright, this is pretty hacky. I'll just clean it up after this is correctly coded. Hopefully. I don't know if this works. Probably has a bunch of errors. Oh, it's very ominous. Alright. It's a backwards traversal up the little hill. Okay, so I think I can delete this stuff here. So no more prefix dictionary, it's just all inline or single pass to create the calculated values as I would calculate the prefix array originally. For every value and position. Yeah, that's necessary. Current 0 for every index in the position and value array. Position is P. This should be factorable. K times P. What happened to my algebra skills? What the fuck? This should be simplifiable. So P is multiplied by K here, and P is multiplied by positive K. P is multiplied by negative P num minus 1 minus K. So I want to say that the minus k and the plus k should cancel. Like it'd be positive kp here and a negative kp here. So otherwise it'd be, oh my god. Now I'm getting lost in the sauce here. This should be total minus p minus 2 times current minus p num minus 1 times p. I'm not sure where this came from actually. If there's a minus 1 times p and there's another minus p here, so it'd be minus 2 times p. Okay, I think that's the same algebraically. It is not the same algebraically. Oh my god. Okay, let's slow it down here. So k times p, negative k times p, they should cancel. Minus current here, so that should be minus 2 times current. Total minus p, and then this should be p num minus 1 times p. Oh, I'm an idiot. I distributed that wrong. So this is a minus p here, but then this is negative, so it'd be positive p. And this is negative p, so that cancels. So it should be just p num times p, like that. Okay. Oh my god. Oh my god. What is wrong with my skills? Okay, minus p here. This is a minus of a minus 1 times p, so that should be positive p. So that should cancel. Minus current, so it should be minus 2 times current. Oh my god. Okay, let's go back one step to make sure that this is right. Okay, come on. Okay, so this is, let's see, so x equals kp minus current plus total minus p minus current minus p num times p plus p plus kp. Oh, plus kp. I'm such an idiot. X equals 2 times kp, and then the minus p and plus p cancels, so there should be a positive total, and then minus 2 times current, and then a minus p num times p. Okay, so it should be calculation equals total minus 2 times current minus p num. I guess I can just do p num plus 2k. No, it would be minus 2k. Or it should just be positive here. And it'd be 2k, 2 times k minus p num times p. Okay, I think that should finally be correct. Okay, yeah. This is absolutely going to do nothing for the nothing for it. What? It's the simplification of the calculation. Somehow that still went from 155 to 1. So like 10% again. Okay, sure. This is kind of the original formula. And then this is the algebraic simplification. Algebraic. How do you spell algebraic? Algebraic simplification. Okay, so do I even need a deck? Could I somehow avoid using a deck? Probably not. Could I use a list instead? So stack things onto the list. No, it's just too much work. Too much work. Alright, this is good. This is as good as I want it to be anyways. Guess it came out pretty short. Okay. Okay, so in summary, this is going to be okay. Broke or I guess broke is maybe a less precise term than decomposed the problem into a few parts. So I guess maybe the first part is to identify for each value the list of positions where that occurs. Used a default dictionary of lists to map each value to its position list, iterated over the nums array with an index, and appended to the list as appropriate. So that was just the first simple step. It's just simply this. You have your variable for the default dictionary, and then you have your indexed loop, and you append to the position at the value, that list, the position. Okay, and then secondly, I guess I should say that in my work, I had prefix and suffix arrays to decompose or to simplify the calculation further, but that got removed as I wanted to improve efficiency later on. So the second part after the removal of the prefix array is for each list of positions, calculate a kind of double-ended queue of corresponding sum of distances for each position in the list. Basically, those values will be appended to the answer array at the appropriate spots. So basically, if the array of positions of a value is something like 1, 3, 5, and then some position p, and 10, 11, 13, 15, then let's say the total is equal to 1 plus 3 plus 5 is 1 plus 3 plus 5 is 9, and then this is going to be 49, so it'd be 58 minus 58 plus p is the sum of all the position values, and p is some value between, like, let's say 5 and 10 here, right? And then the distance, the total, the sum of the distances is going to be like so it'd be 3p, like p minus 5, p minus 1, p minus 3, so it'd be 3p minus 1 plus 3 plus 5 is how far p, whatever that position is, from the starting position, and then it'll be like 10 plus 11 plus 13 plus 15 minus 4p, because it would be 10 minus p, 11 minus p, 13 minus p, 15 minus p as the distances from p to the later values. And since there's 4 things here, then there's going to be subtracting 4p here. And similarly, since there's 3 things here, there's going to be 3p minus those 3 things. More generically, distance that position p is from all the other positions in array of positions is equal to, let's say, sum of prefix to p, or let's say it's like this 135 is like the prefix of p, so it'd be the index k times p minus the prefix up to k, plus here this is total minus the prefix up to k minus p. That's the sum of these values, and then minus like the number of values p num minus k times p. So like these all correspond to that, and this thing corresponds to that, and this thing corresponds to that. And then just do some algebraic simplification there. So like this was the original formula, and then this is the algebraic simplification, which actually did lead to some improvement in speed. Okay, anyways. And then for create answer array, iterate over the values in the nums array when on a particular value, get the calculated sum distance for that value from the deck of that value, and pop left to remove that calculation. So it's the deck is going to temporarily hold the calculated values, and then it gets removed one at a time to add to the answer array. All right, time complexity is going to be O of n, I want to say, where n is the length of the array. All the calculations are constant speed, and there are a number of times where it needs to iterate over all values or all positions of those values, both of which are n in length and in size. Space complexity, this is open to store the default dictionary of positions. Yeah, and also to store the calculation for distances.